Welcome to this online demonstration of some of the features of TreeAge Pro. The goal of this demonstration is to learn how to perform Markov cohort analysis and to understand how to interpret the results. The analysis will return expected values for the entire cohort and not for individual patients. This demonstration looks specifically at a Markov model but does not interpret the results for a large decision-making model, which may incorporate one or more Markov models. This demonstration will use the 2014 version 1.2 of TreeAge Pro. Firstly, we want to make the distinction between Markov analysis and patient-level or microsimulation. With Markov modelling, we will be running an entire cohort through the model to get expected values for the cohort. In cost-effectiveness modelling, these are likely to be expected values for cost and effectiveness. Those expected values could then be used for cost-effectiveness analysis to choose the best treatment strategy. Certain Markov models will require patient-level simulation, also called Monte Carlo or microsimulation, because this will allow us to store data at the individual patient level. In previous demonstrations, we have explained the concepts which apply to Markov modelling, and we've also built the example which we currently have open, example 8 from the healthcare training examples. You should refer to both of these demonstrations for more details about the terminology specific to Markov models and for also information about how to build a Markov model. We'll use this example 8 from the healthcare training examples, Markov cancer, to go through the analysis steps. In summary, this example has 3 health states. It has local cancer, metastases, and dead. And the entire cohort is going to start in the local cancer state. State rewards for cost and effectiveness are accumulated for the proportion of the cohort in local cancer and metastases at each stage, and the model will run for 20 cycles. Probabilities in the transition subtrees are going to define how the cohort transitions among the health states. Please refer to earlier demonstrations for more information. To run analysis, select the Markov node, go to the Analysis menu, select Markov cohort, click, and the output is a table of results per stage and also a table on the right hand side with different text reports and charts. Let's talk through the output that we have for one cycle. So let's double click on the tab. The first column gives the cycle via the stage keyword, and the second lists all the health states. For each health state, local cancer, metastases and dead, the proportion of the cohort in each state in a given cycle is given in this third column with the heading probability. The next 2 columns, state cost and state effectiveness, give the state rewards per health state for that stage only. So this is the number of rewards of cost and effectiveness in stage 0 for the local cancer state. The state reward is calculated as the proportion of the cohort in a given state multiplied by the reward entered for that health state. The next 4 columns give the stage cost and effectiveness first per stage and then cumulatively. By dragging this across, we can see those things here. Stage cost, cumulative cost, stage effectiveness and cumulative effectiveness. Note that the rewards are only accumulated for the proportion of the cohort who are in a given health state. In this example, there are different costs and effectiveness associated with being in local cancer and metastases, so the rewards associated for each state depend on the proportion of the cohort in that state multiplied by the reward for that state. This model does not include transition rewards associated with events in the transition subtrees. If those values were being accumulated, they would be reflected in the output as a destination state rather than a starting state. So if they occurred in the local cancer state, then the transition rewards would appear in the next stage in the destination state. This model only shows the active payoffs for cost and effectiveness. If we had set the model via the tree preferences to calculate any additional payoffs, these would be shown in subsequent columns to the right of this main output. As we progress through the stages from 0 to 19, we accumulate cost and effectiveness as reported in columns 7 and 9. So this is the stage cost and stage effectiveness. At the bottom of the report, we can find the total expected values for cost and effectiveness accumulated over all states and cycles for this cohort. This is shown in stage 20, which we can expand here. Stage 20 never actually runs but reflects the values after the last cycle, that stage 19, is complete. So that these values here are of stage cost and stage effectiveness. This Markov quick analysis is useful when you're getting an overview of what is happening to the cohort over time. If we want to check the model in more detail, then we use the Markov full analysis. The results in Markov full can allow you to follow the entire pathway of a cohort as they move through the model, and it's a good tool to use when debugging the model. So again, we'll go back to the model, select the Markov node, analysis, Markov cohort, full.
In the dialog box that open, there are a few settings that we need to look at. First of all, we want to report the probabilities as decimals. I'm not interested in looking at a cohort size at the moment, but if we were interested in a cohort of a specific size, we would select this radio button and enter the cohort size there. I also want to make sure that I can see both the stage and cumulative rewards. So I'm going to check this radio button here, and as is already selected, we want to include the per state rewards column. I don't want to run the whole model, I just want to look at the first 5 stages. So let's go from 0 to 4, and that will run 5 cycles for us. And select OK. And you'll see that the output at initially looks very similar to the Markov Quick, but it has more information into which we can expand. So let's do that now.
At stage 0, we see that a total of 1, which is the whole cohort, starts in the local cancer state. Within the local cancer state, we see that 83% of that cohort will stay here, 15% will progress to metastases, and 2% will die. We can then also look at the state cost and effectiveness. And the state rewards for cost and effectiveness accumulate for the proportion of the cohort who started in the state. So in this case, it's the whole cohort. In this particular model, we know that we have half cycle correction implemented, so only half of the local cost and effectiveness are accumulated here. So with a local cost of 20,000, we see that half of that, 10,000, is accumulated as a state cost. At stage 1, we know that there should be 15% of the cohort have moved to the metastases state. And we can see that here, 15% start in the metastases state. Once in the metastases state, of those 15%, we have 90% who will remain here for the next stage, so they'll survive, and 10%, so that's 1.5%, who will die. And we can see that reflected in these numbers here. For rewards, we can also see that the state cost for metastases is accumulated at 15% of the total cost of metastases, that's 50,000, to give 7,500 as the state cost. And similarly for the effectiveness. Let's finally look at the stage called stage 2 down here, which is actually the third stage in the model. And we're going to look at the dead states. There are no rewards in the dead state here, so no cost and no effectiveness, but we can see the cohort has now started to reach the dead stage. We know that from stage 0, so that was the first stage in our model, that 2% of our cohort would pass to stage 1. Then at stage 1, we have 1.6% of our cohort die from local cancer. And we also have 1.5% who die from metastases. So then we can look at stage 2, and we can see that in the dead state, we have the sum of all of those that have died. That's the 2%, the 1.6%, and the 1.5%. Following the cohort through these health states will help you understand and debug the model if required. Both the Markov Quick and the Markov Full analysis have the same output reports, which appear on the right-hand side.
So let's have a quick look at those now. So the first one is the summary report. And this just provides tabulated output in two-dimensional grid, which is good for exporting to Excel if required. So it goes through each stage and lists down everything that we'll need to know. The state prob output in charts shows how the cohort is split among the different health states. In our example, we have 3 health states, so the results show the correlation between local cancer, dead, and metastases. The next output in charts is a survival curve. And we can select the survival curve and are prompted to enter the non-survival states, which in this case is dead. Select OK, and that generates a survival curve for us. We have the ability to toggle between the different outputs. So this is going to show us survival versus non-survival. Generates a second graph for us showing both survival and non-survival, and then selecting the filter again. The final four charts which we've got here give both the stage and the cumulative cost and effectiveness, so the rewards, and it gives us a way to look at the rewards as we go through the model. In all these graphs, we need to note that there are going to be 0 to 20 stages indicated in our model. And it's important to note that this final stage here isn't actually a stage of the model that's run, it's actually where we accumulate all the rewards. It's important to note that once the Markov model component of your models are built and tested, you no longer need to run Markov cohort analysis. These Markov models are usually part of a larger decision tree using the total expected values calculated from the Markov cohort analysis. So let's have a look at an example of this. We'll reduce the size of this output and we'll select example 9, Markov cancer decision, from the healthcare training examples. When this example opens, you'll see that there's a decision node here with 2 Markov models within there. This example would be run by selecting cost effectiveness analysis from the analysis menu, and no Markov modeling would be required once you've tested the components. Please see the cost effectiveness analysis demonstration for more details about the analysis of such a cost effectiveness model. To recap, this demonstration has covered how to run the Markov analysis for a cohort using both the quick and full methods. It's also covered the outputs provided by running Markov analysis and how they can help ensure the model is acting as we intended at the Markov model. Thank you for watching this demonstration by TreeAge Software.